Let us continue classification of voltage stability analysis tools. First one already we discussed primary phenomena related to system structure reflect the autonomous response of the system to react to supply demand imbalance. Right. So already we discussed. We'll go to second one. Uh, Second one is secondary phenomena related to control action reflect the counterproductive, right? So it's like a relate control actions reflect the counterproductive. I mean, like if suppose production is normal or any demerits will be there in the generation or in the production of a power supply, so it will be giving a counterproductive. I mean, like it will be giving more production counter to the that production, right? To nature of the some manual or automatic control action. See, smart grid is always automatic or intelligent power supply system, right? So it's it will concentrate on more automation, I mean automatic. Next, tertiary phenomena resulting from the interactive of the above. So just considering both primary as well as secondary, I mean first one and second one. So combining those two, there is a if suppose a disadvantages will be there, or if suppose drawbacks will be there in these those two, definitely the third one will take action and it will make it as in proper way. So that's a third one. Next we have static stability type. I mean first one is a type 1 instability. Suppose that the delta xs or delta is equal to delta xf is equal to 0. It's a static constant, that's why they have taken on 0. Then we have static situation with all the equations being algebraic. So in this smart grid techniques, we have algebraic calculations, algorithms for the calculation, and so many procedure will be there. Like simulations will be there for executing the overall system. So analysis technique for a dynamic voltage stability studies. So static voltage stability, it's a constant. Dynamic, it's a fluctuating. See, suppose 230 volts or some voltage will be there, or some power system standards will be there. So that will be changing. It depends upon the environment also. It depends upon the consumer side also. So it must be changes, right? So that's a dynamic voltage stability study. It is only recently that the effect of the system and load dynamics have begun to the investigated. So in the context of voltage collapse. So if suppose voltage collapse occurs, there is an investigation will be there. Dynamic, I mean like continuously it is changing, right? The dynamic considered are machine execution system dynamic, including power system stabilizer. So power system stabilizer PSS, right? uh, in this we have controlling of voltage, or if suppose input is some difference will be there, or some fluctuation will be there, so output it becomes like constant, and it stabilizes the overall system. And load dynamics. So if suppose load dynamics in the sense, everybody knows, if suppose if the power play usage will be a variation occurs, like it will be varying time to time, or and also it depends upon the appliances we are using, or output applications. Dynamic SVC controls, and then facts. So flexible AC transmission system, and it's it depends upon even dynamic voltage stability. Flexible AC supply system, I mean, like if suppose extension will be there, and then expansion will be there, in the sense, so it will be managing, I mean a stable system. Tap changing dynamics. So tap changing in the sense, like changing the power supply system from one level to another level, or one supply system to other supply system, right? So level by level. So suppose 0, 20, 30, 40, 50 will be there, or till 230 or 11 kilovolts. So that's tap changing. Next, dynamic due to load frequency control, automatic generation control, and so on. So dynamic system stability depends upon generation also. If suppose generation variation will be there, it may like changing voltage level. So that also depends upon voltage stability to the dynamic stability analysis. and so on. Next we have voltage stability techniques. So we have one block diagram over here: voltage stability assessment techniques, VIPO, singular value decomposition, bifurcation, continuous power flow, energy functions. So voltage stability assessment techniques, these four methods we are going to follow, and where these methods are like to maintain the voltage levels and then voltage control accessed by these five techniques, right? So first one is VIPA, voltage and power. It depends, and voltage, current, power also will be there, and a singular value decomposition and bifurcation, and energy functions will be there, means that's a, and continuous power flow. So continuously power will be flowing from generating station to the power supply system, right? So that's also very much important.